So the last couple of things we talked about in class with complex numbers was multiplying them. And we said we can use the distributive property, we could use FOIL, and the idea was that special products come up and we can use the formulas as they are. So in these last two examples, the special product we're demonstrating is difference of squares. And what I'd like to focus on before we start division is just multiply the most general pair of conjugates. So these two are called complex conjugate pairs. Because they have the same real and imaginary part, except that the imaginary part is the opposite sign. When you multiply these out, as you can see with the last two examples, you just add the squares of the real and imaginary parts. A squared plus b squared. So this identity we're going to use when we're dividing. It's going to come up quite a bit. And take a note of what complex conjugate pairs are. Okay? So let's talk about dividing complex numbers. So remember that whenever we do an operation with complex numbers, we want the final answer to be in standard form. So let me remind you that the standard form of a complex number looks like a plus bi. Okay? So here's an example where we have to divide two complex numbers. Four plus 3i in the numerator divided by 1 minus 3i in the denominator. So to divide these complex numbers, we take a look at the denominator and multiply the top and bottom by the complex conjugate of the denominator. In this case, the conjugate of 1 minus 3i is 1 plus 3i. So we're going to multiply the top and bottom by 1 plus 3i, okay? Because 1 plus 3i is the complex conjugate of the denominator, 1 minus 3i. Okay? So let's start, we're going to multiply the numerator and denominator. Let's start with the denominator, because the denominator fits that special product we just mentioned, because it's a product of complex conjugates, so it's just a squared plus b squared. So for our example, the denominator is just going to be 1 squared plus 3 squared. Now in the numerator, we'll write this as 4 plus 3i times 1 plus 3i, and use the distributive property or use FOIL. So in the next step we're going to do that. The denominator is 4. The numerator is 4 plus 12i plus 3i plus 9i squared. Okay? Now, combining like terms, 12i and 3i, we get 15i. So we get 4 plus 15i plus, replace I squared with negative 1. That's another important thing we talked about, that we replace I squared with negative 1. So this will be plus negative 9. And still we have a fraction all over 4. Now finally, combine the real parts. So the real parts here are 4 minus 9 is negative 5 plus 15i all over 4. And the last step is to write it in standard form, as we said above. So we're going to have to separate these into two fractions. The final answer should look like negative 5 over 4 plus 15i over 4, or 15 over 4i. So this is the final answer. So let's take one more example. As a matter of fact, For this example, just to practice, what I'd like you to do is I'd like you to pause the video and see if you can work this out yourself. The question is negative 3 plus I over 5 plus 3I. So go ahead and pause the video right now and come back and we'll do this together. Okay, so let's work on this together. Step 1 is we're going to multiply this by the complex conjugate of the denominator. That comes from 5 plus 3i, so it'll be 5 minus 3i over 5 minus 3i. And essentially what we're doing here is multiplying this fraction by the quantity 1, so it doesn't change the value. Okay, multiply numerator and denominator. I start with the denominator. This is again that special form of multiplying complex conjugates, so it's a squared plus b squared, 5 squared plus 3 squared. The numerator has negative 3 plus I times 5 minus 3i. Okay, the denominator is 25 plus 9. The numerator, I will use FOIL here, so negative 15 plus 9i plus 5i minus 3i squared. The denominator adds up. 25 plus 9 is 34. Now, combining the imaginary parts, we get negative 15 plus 14i. And then I squared is replaced with negative 1, so that last term becomes plus 3. Finally, combine the real parts. Negative 15 plus 3 is negative 12 plus 14i. And all of this is over 34. Now separate these to write this in standard form. So we're going to have negative 12 over 34 plus 14 over 34i. And then simplify these fractions. Negative 12 over 34 reduces to negative 6 over 17, canceling out a factor of 2. And similarly, we get 7 over 17i, again, dividing by a factor of 2. So that's your final answer. Let's take one more example. Okay, so in this example, we're going to divide a complex number by a pure imaginary number. We're going to divide negative 4 plus I over 3i. So here, you can think of the denominator, always write it in standard form first. So this is 0 plus 3i. So the conjugate of this would be 0 minus 3i, and of course I can just write negative 3i. And that's the number you're going to multiply by. So you're going to multiply the numerator and denominator by negative 3i. So we get, in the denominator, negative 3 times 3 is not negative 9 times I squared. In the numerator, we have negative 4 plus I times negative 3i. Of course, here we're going to use the distributive property. So negative 3i times negative 4, and then negative 3i times I. So we get, let's see here, 12i minus 3i squared. And this whole thing is over negative 9i squared. Now replace I squared with negative 1, then we get 9. Alright. Again, replace I squared with negative 1, we get 12i plus 3 all over 9. Alright, and finally we have to write the real part first, and we have to separate these, so we have 3/9 plus 12/9 I. Simplifying these fractions gives 1/3 plus, dividing by a factor of 3, 4/3 I, 1/3 plus 4/3 I. That's the final answer. So in summary, you want to write down the numerator and denominator in standard form. You want to multiply the complex conjugate and simplify. Make sure your final answer is in standard form.